Hi everybody, welcome to the webinar today. We're going to talk about SOLIDWORKS Inspection and taking our first steps with the program. So how do we get started once we get it out of the box? And before we do that, I'm going to run through a quick product overview. And basically, I'm going to go through in a quicker manner what we'll be going through step by step later. Because we have some people in attendance who are just interested in the program and want to see the power of SOLIDWORKS Inspection, see what it can do. So let's take a look at kind of, what's the need that this is meeting. And that is, of course, inspection documents, right? So certain industries have requirements for inspection documents for their parts, but also, maybe you just want to inspect a part to make sure that the tooling is okay with your machines, or that, more importantly, the part output meets the engineering drawing specs. And this is done maybe on either a one-off part, make sure it's all set up right, or if you're going to make a large run of parts, you want to inspect a sample size. This is also good for that as well. And we have a couple versions of SOLIDWORKS Inspection. We have the standard and the professional. The professional has some added features. Mainly, if you're using a CMM machine, you can easily import the data into SOLIDWORKS Inspection and incorporate those and match up the values real nice and easily. That's really the main thing. There's some other extra measurement inputs as well that are included with the SOLIDWORKS Inspection Professional. Now currently people are doing this usually by hand, right? You print off your drawing, you'll manually balloon, put numbers associated with dimensions or notes or other items, and then you'll make an Excel document where you will manually calculate the upper and lower limits of the dimensions and write in all the notes and things that you might want to inspect. So this is, of course, a very manual, labor-intensive, time-consuming process, and it's very prone to errors, right? What if we mis-enter one of the calculations or something like that? So we're trying to reduce all that, make this a lot faster, less error-prone, and in the end, saving time will save the company money. Right, we have a quality assurance inspector who gives a little quote here. It says, takes about 2 hours to balloon a drawing and another 2 hours to create an Excel spreadsheet. Right? And that's just maybe for a typical drawing. It could take less if it's a smaller drawing. It could take longer if it's an even larger drawing. So we'll see the power of SOLIDWORKS Inspection and see that this can do this in a much quicker fashion, saving quite a bit of time. So in the engineering workflow, SOLIDWORKS is meant to handle, of course, the part design and assembly design and 2D drawings. And then we've got products like CAMWorks to help with manufacturing, but then after the part's made, we have to inspect the document, make a report, and then from there determine if there's revisions needed and if we need to do the process all over again. So that's kind of the realm that we're working in with SOLIDWORKS Inspection Standard as well as Inspection Professional. And again, the main differences between the two packages are the Inspection Professional handles the CMM data input. So if you're using a CMM machine and you need to run inspection documentation, you should definitely look at SOLIDWORKS Inspection Professional. Now the standard version will allow you to do all the inspection ballooning and Excel output documents that you need. But again, that CMM data input is with the professional. And there's also some extra measurement inputs directly into the program as well as color-coded results, so you can get a nice picture of multiple inputs on one part document. All right, so let's take a look at the add-in for SOLIDWORKS. So the SOLIDWORKS Inspection comes in a little tab right here. It's an add-in that integrates right into SOLIDWORKS. So I have a SOLIDWORKS drawing. I can pull out the metadata from the part file or whatever I'm drawing out here. And then all I have to do is choose my numbering scheme. I can tell it what I want to balloon and then give it a tolerance on my dimensions and let it go. And what it's going to do is put a balloon on all the important stuff that I've specified, dimensions, geometric tolerances, notes if needed, and then it will automatically calculate the upper and lower limits. So like if we look at this one, number 17, 1.500, we have an upper and lower limit of 5 thousandths, so we have 1.505 upper limit, 1.495 lower limit. So it'll automatically calculate these. And if we have any specialized ones like this one here, 0.25 plus or minus 0.003, right? That's got different tolerancing, so of course it has a different upper and lower limit. So there's some intelligence to this, of course. So then, if we want to export to our Excel so that we can actually take this document to the part and measure it, And we can set up our Excel template so that we can have color-coded results if we'd like. So I measure this, it's 22.00. That's right on the money, right? Green. Or maybe I measure this 1.98. That's red. That's bad. So that's just set up with all the conditional formatting in Excel. So that's the add-in, right? That was really quick and easy. So let's look at the standalone version. And this works with PDF and TIFF documentation, so you don't even need SOLIDWORKS to run the standalone version. And also, the other customers you're interfacing with don't need SOLIDWORKS as well. They just need to be able to send you a PDF or a TIFF document. And this uses optical character recognition. So all I have to do is draw a box around the things that are important to me, like maybe that note, those dimensions. I can even capture some geometric tolerancing and other things just like before, surface finishes, welds, other information that might be important to me. And I can always recapture if I need to. So like this note, let's just do a quick recapture because I want that to be bigger and capture the whole thing. And that's good. So if we look at one of these dimensions, like this 16 plus or minus 5 thousandths, upper limit 16.005, lower limit 15.995. That's great. And we can do the same thing as before. We can also export to PDF and Excel so that we'll have a PDF printout of our ballooned drawing. And then let's get an Excel, just like before with the add-in. We can export this to Excel. We can create our own custom templates if we would like. We're not limited to what we see here. And how to create those we won't necessarily go over today, but hopefully there'll be some more information on that on either our YouTubes or our blogs or any of the other great resources that we've got out there. So this Excel behaves the same way. I can set this up with some conditional formatting. So 1.495, we'll just put 1.5, right? Something in the middle, it's good, green. Maybe I measure this one and it's way off, 14, that's red, bad, okay. Okay, so let's take a look. So here again we have SOLIDWORKS Inspection Standard and Inspection Professional. And the main thing again with Inspection Professional, CMM data input, it's extra measurement input. Today I'll just be covering the SOLIDWORKS Inspection Standard so that we include everybody in this e-learning. So let's go back to the SOLIDWORKS add-in and then go through in a much slower click-by-click fashion and also tell you a few things to think about as you're creating these inspection documents. Okay, so we're in our SOLIDWORKS software, and to turn on the SOLIDWORKS Inspection add-in, you want to go to here, the drop-down, or Tools, Addins. And here's where you turn on all your either premium add-ins if you've got SOLIDWORKS Premium or any other add-ins that you may have purchased. You want to make sure that's checked on. And then you should get a tab in the command manager as well as a supplemental tab, the SOLIDWORKS Inspection tab for when you're in the drawing. So the part's made, drawing's made. We can think that the part would be manufactured by now, or we can even create the inspection documentation to send to the manufacturer if we would really like, or maybe this is for a QA guy. So we want to start with a new inspection document. And we can either click on this new inspection project or this one down here. Let's create inspection project. And we can type in whatever we want in these boxes, but the whole idea about the inspection, of course, is to avoid all that manual input, and instead we'd like to be able to pull out from either file property metadata or, in case of the standalone, the OCR recognition. So if I click right on where it says part number, I can pull out from any of the file properties in anything that I have. And that would be the drawing, that's got its own file properties. I've got model properties from the model, and then model configuration specific. So let's take a look at that in a little bit more detail. So I'm in the SOLIDWORKS drawing file properties, this button here, or file properties. It has all this information that we can, of course, pull into the inspection documentation. If I open up the part file, I've got the same thing. I've got custom file properties and I've got configuration specific. So if there's multiple configurations in the model, you can tell it which one you want to apply the file property to because it may be different than another configuration, right? So custom is like the overall for all the parts. Configuration is configuration specific. Now when you're making a SOLIDWORKS drawing, the configuration specific will usually override the custom ones in the bill of materials, but with inspection you're picking and choosing which one you want. So I've got part number and all that stuff all set up already. So let's find that again. So part number, I can just click on the tab for where it is, click on it and hit OK. Part name, same thing. Let's call it fixture housing. And then part rev, I've got the first edition, so this is rev dash. And I can type in whatever I want if I needed to add more stuff here. I can tell it how I want to start the balloon numbering and the order I want it to go. And then the sampling rate, this is based off the ANSI Z1.4 document. It basically, you just put in lot size, the level, sampling type, and the acceptable quality limit, and it will output sort of your sample size and your accept and reject numbers, and you can build a template to sort of contain that. So we won't really look at that too much more. If you want more information on that, please contact our tech support later. So you click the next, and then here's where you can tell it what you want to bring in. Now, when you're making a SOLIDWORKS drawing, you've got the dimensions. You can specifically tell it these are inspection only, right? It'll put that kind of oval around those dimensions, and then you could filter out those ones here really quickly. Or you can bring in the reference in basic, like I'm going to do here. At the bottom, you can also tell it if you want to search for geometric tolerance boxes like I've got here, or hole callouts, welds, and surface finishes. Those are the ones it'll look for. And I'll also try to extract notes based on that extraction criteria using, the search methods there. So once that's all set, we can click next and then set our project tolerancing. So if there is a specialized tolerance, like we've got this 1/4 inch plus or minus 0.003, that will have some intelligence and recognize that. But other than that, we have to tell it what tolerance to look for if there's none apparent already. So it's not going to pull from like a sheet tolerance that you've typed in. You have to enter it here. So like if I click on angular, I say, okay, if it's 1 decimal plus and minus 5, that looks good. Other than that, I can just change whatever I want. If I want 0.25 or whatnot. So set that all up, give it the right units, and then just hit the check, and it'll start to go. And so it'll automatically balloon everything, and if you delete a balloon, it'll automatically renumber. If you add more dimensions, you can have it renumber or reorder the balloons as well. And so it's pulled out all of the stuff I told it to. And if I want to find them, I can either go here on the characteristic tree, you'll see it's kind of filtered all these things out, or I can click right on the drawing. And when it's here, you can reposition them. You can click right on the balloon and reposition the balloon. Like these ones are kind of cluttered, right? Maybe I want to drag that over, drag this over, and then reposition them. And to select the balloon specific, you want to click on the actual dimension it's related to. So if I click on that weld, it says, okay, that's the 13 dimension, and it's recognized that on the arrow side there should be an 1/8 inch fillet weld. And the same thing, we can take a look at like this angle and make sure that 1 decimal, yep, plus or minus 1/2, and it's calculated the upper and lower limit satisfactorily. We can also specify, if I go to the bottom of the properties box, the method which we are telling the QA guy to measure this with. So for instance, if I go to this surface finish and I go to the method and I say I want you to use a dial indicator to measure this, that might make sense. And also we can, if we go to the SOLIDWORKS Inspection tab, we can edit the inspection method. So maybe for the weld, I don't really have it specified anywhere, but maybe I wanted that vacuum type. So I could go to Edit Inspection Methods, go to Add, and just put in one here, vacuum leak test, and hit OK. And now when I click on the weld, I can click that, and we'll say it should be at the bottom there, right? Vacuum leak test. So we can customize those. So we can customize the inspection methods, the operations. If we look at those, we can specify what this is, referring to as far as operation of that dimension, how it would relate. Also the vendors. So at the beginning, we set up the project, and we could tell it, what vendor this might be coming from, or maybe who the manufacturer is, just to get a little bit more information on our part, right? And here at the bottom, you'll notice there's a sample size accept and reject, which would have been calculated if we had entered the information in the beginning. Okay, so if we don't want a balloon, again, we can click on the dimension, go up here and uncheck the selected, so we can do that, and then it'll reorder the balloons as appropriate. If we go down, if we want a key dimension, like if we go down to the surface finish, say, what, you know what, that's really important, let's make that a key dimension, and click on it, we'll reorder everything, and mostly it's just changed this to a triangle shaped balloon. And if we go to any of the other ones, we can also make them key dimensions as well. If we click on that little balloon setting here, let me go back there. This one that says it's got a 1 with a star on it. We can tell it, sort of how we want these balloons. If we want them attached, we can change the shape of the balloon. Maybe we don't want them circles. We can define how that key dimension, or sorry, key characteristic is shaped as well. So right now, there's some different shapes associated with that. So once we've got this all set up, then it's time to export. Export to Excel. And out of the box, you'll get all of these, not this second one on mine, that's for something else, but you'll get the AS9102, the large logo template, PPAP, and process performance sheets. And you can kind of play around with these. They just give a different format in the Excel output that you're getting. So if I click the OK, we can take a look at that again. So here's the output that we're getting. So you'll notice the weld, how that pulls in, it says arrow side, 1/8 of an inch, fillet, other side, nothing. And also the geometric tolerance, it puts a little picture of it, which is appropriate, and then it calculates all upper and lower limit, right? So it saves you basically just a lot of time. And the how you're supposed to measure it, right, vacuum leak test, that was appropriate for that one. And then there was another one that I don't think I added this time, but so that's all there. So let me close this out. And if you want to edit those templates, you can go right to this Launch Template Editor. Click that, pick a template you want to edit, and then start playing around with it. Right, we won't really get into that much today, but there hopefully will be some videos up on our YouTube site within the next few months, so keep checking back there. Okay, so that was our add-in. And now let's take a look at the standalone product. So let me go here, let me just close this down, and I'll start it up again. So the standalone product is really great because you can interface with people who don't even have SOLIDWORKS. People who, let me get out of this real quick. So people who just give you a PDF drawing or a TIFF, so it brings in PDFs or TIFFs, and then you can interact with it that way. Let me go, doesn't seem to be starting up here, 1 second. There we go. All right, so let's pull that up, and we'll start with the standalone. So again, when you purchase it, you get standalone as well as the add-in. All right, so we got the standalone open, and so you're going to get this interface when you first start up the standalone version. And you want to start with a new project, and here we have some default project templates, and these are just a culmination of the options that we'll look at a little bit when we enter the program. And we've got some different languages that you can, be supported. So DE, usually German, FR French, and then English is the one we want here. It doesn't have any other dots. And there's also a few other templates. So if I hit OK, now it's going to tell me to search for a document to start my inspection sheet. So I've got this that fixture housing drawing. I just saved it off as a PDF. If you look on the bottom left here, it says it can accept a PDF, TIFF, TIF, or TIFF, TIFF. So if you want to work with a native SOLIDWORKS drawing, use the add-in. If you have a PDF or TIFF, then use the standalone version. So hit the open. All right, so it's open in our interface. So with the standalone, for one, again, SOLIDWORKS doesn't have to be open for this to work. Anytime you see this little push pin, that'll let you automatically, hide the menus and let them disappear, or you can pin them down and they'll stick there. And so last time we clicked on, part name and then looked through the metadata. Well, this is just a PDF image. So we could, of course, type in again, but if we click on this little plus box thing, we can just left click and draw a box around what we want, and the OCR will pull the text and put it in the appropriate box. So that's where the real great time saving is. So I've got fixture housing, part number, maybe if that's not on there, I'll just type it in, and then I can select whatever else I might need to here. So maybe drawing name, I'm just going to try to select HRS e-learning. If that doesn't come in all the way, right, you can just kind of correct it, or redraw the box, which would have been just as easy. Okay, so hit OK, and let me pin down the characteristic window here. So now you want to start capturing the notes, dimensions, tolerances, surface finish welds, or anything else. So if I've got this note block, I'd like to capture that. I'll click on note, and then just left click and draw a box around there. And so it's going to give what it thought it recognized. So if that doesn't look so good, I can either go in and edit that, or I can click this button here, which says Recapture Selected Characteristic, and then just draw a new box and see if that gets it a little better. Right? That one's got some weird symbols, so maybe not. Let's try this one here. Right? That looks pretty good. Paint letters, HRS blue. So if we need to recapture, we can always do that. Let's click on Dimension and start capturing these dimensions. And with the dimensions, it's usually good to just do them all at once and then go back and review them. That way you don't spend too much time reviewing ones that, when you could just be doing more. So I'll draw a box around most of, if not all the dimensions, because it's pretty quick and easy. There's another one down there. And then let's capture the surface finish. So click surface finish. I'll come down to my drawing, capture the surface finish. I'll click weld. I'll go up to the weld area there and capture that. All right, so a couple things here. If I pull up this window here in this table manager, all these characteristics are being built in here. So all this stuff that I've drawn a box around, it's appropriately found the right tolerances that are specified in the options. And if it's got a specialized tolerance, it's put that in as well, and then it's got an upper and lower limit ready to export to our Excel. So if we want to see one of these, we can click right on that in the Bill of Characteristics window. It'll pull that up. Or we can even click right on the graphics window, and it should cycle through to the balloon. And just like before, if I want to recapture that image, I can click on this Recapture and just draw a new box around there. I can also just click and drag this dashed box to reposition sort of where this thing is looking. So for the weld, I wanted, if I click on Inspection down here, for the method, I wanted vacuum leak test, right? So I could add that into the methods, or I could just type it in right here, right? Vacuum leak test. So let's go look and see how we could potentially add that in. If I go to the Home tab and go to the Options, let that load in here. If I go to Lists, here's where I can edit all the different methods that I might want to put in, or all the operations I might want to associate with this, or the classifications if I'm doing some statistical analysis on my parts. So like here, I could have typed in, put in a plus, put vacuum leak test, and then hit OK, and then that will be available in this drop-down menu. So within the options, here is also where, if you had a project options general, where you can set your tolerancing. So I've got, certain tolerances for length, certain tolerance for the angular units. Maybe if I've got 1 decimal, I actually want that to be 0.5 and minus 0.5. Okay, and these other ones, maybe I'm never going to have that, so I'm just going to leave it the way it is. Here's also where you can specify what the balloons look like. So you can have the balloons be different shapes, just like in the add-in. The only difference is the key characteristic is going to follow whatever the other balloons look at. But the difference is going to have whatever you type in here. So if you want to say key, if you want it to K, capital K, whatever you want to put in there, it'll place in for key dimensions. And you can, of course, change the colors and all that stuff as well. Now, if we look at the Imaging OCR tab, here's where you would want to change this if you're using a different, maybe a PDF that came from a different CAD system, or maybe you're not necessarily getting the OCR to work as well as you know it should. You could come in here and kind of play with some of these options and then see if you can fine tune it a little bit. So usually this is going to work okay right out of the box though. So I'll hit OK. So let's make we wanted the surface finish to be a key characteristic. So let me click that one and I'll check the box for key, and you notice it puts a little K. I also wanted to specify that that should be done with an indicator, but it's not here. I could add it. I could just type it in. Maybe I'm going to change my mind and say measure with a laser. That's got to be super fine. Okay, so we can also come down to balloons. That just changes the position of where this balloon is relative to the characteristic. You can see it kind of moving around on the screen as I click on this here. And then if there's any custom properties associated with this specific dimension that you want to show up in this bill of characteristics list, you can edit that here as well. Okay, so let's take a look at these other tabs. Well, first off, let me add one more specialized inspection method. That way we can do a little filtering. So let's just say, all right, that one there. I also want to inspect that with a laser or something. So this bill of characteristics, I can filter these by clicking on this little like funnel, or I can even just sort them. Say I click on inspection method, I can click a couple times and sort. So it'll sort by inspection method. I can sort by the value, so it'll organize them from large to small, however I'd like. And then I can right click and say clear sorting if I want to get rid of that. I can also reorder these balloons however I'd like. So if I'd like number 17 is the weld, let's make that number 13 or something. So I just left click and drag the number and drop it on what I want it to be, and it'll reorder that and then scoot everything down after that. Okay, let's see, I noticed we have a question. I'm going to answer that one at the end here. Okay, so let's look at the bill of materials section. So we've got the bill of characteristics, that's just all the dimensions and welds and all that stuff. Now, for the bill of materials, if we want to contain that and sort of either import or extract that. So the differences are this. If we've got already a CSV file, we can import that. And so it's just, a text file basically of the bill of materials and such. Right? But it will come out in the order that this is already at. So if they're not already organized in the specific format, part name, number, serial number, report number, supplier code, it'll kind of jumble them up. So maybe a better method is to extract them from a PDF document, which I've got. So anytime you want to add another drawing sheet or another document to pull up bill of materials or specifications, just say add drawing on that tab up there, and then find your PDF or TIFF, and then it'll pop in here in another tab. So now I've got this, here's just a very simple parts list for what I've got, and 2 halves of my fixture and 1 O-ring. Let's click on extract, and then I'll draw a box around everything that I want to contain. So not the title, just the information that's important to me. And then here on the left, everything up here says unassigned, so I want to right click and assign them to a specific category. So I'll say part number, let's do a serial number, and part name. If I don't assign it to something, when I hit OK, it'll just leave these other ones blank, but it's appropriately ordered them in the right area there. And if I need to, I can click on one of these and just enter in whatever I want, right? As far as typing in if it's not necessarily on my PDF sheet. And this works the same way for the specifications. I could import a CSV file or extract them, and I'd be looking for this information here as far as that part. All right, so we've got all that. It should be noted, let's take a look at maybe the interface real quick, because some of the options, like how the balloons look, that can be set here in the Home tab as well. The drawings, where you tell it where you want to pull the information from if you've missed that. Also, add and remove drawing pages is set here. Also, this grid is pretty neat. So let me go back to the fixture housing sheet and the bill of materials and click on the grid. So this is going to put zone references on our drawing, and we can have them be, it says how many rows, how many columns. So let's do a 4x4, and we can change the ordering if we want to, have letters for rows or numbers for rows or vice versa for columns, and the ordering however it's set. So some of your default company templates probably already have zone blocks set up, so you can have it match as close as possible to that. And so you can do either the whole sheet, or you can click on this little button here and just pull in a specific area for it to put a grid on. Let's do the whole sheet, and that looks pretty good. So when I say OK, let's get rid of some of these menus. And let's look at like number 13, the weld, that's in box 2B, so characteristic zone, that should be 13 2B, right? That should match up. So of course that saves you more time when you're inspecting the part, because you want to make sure that you're not hunting around where's balloon 59, it's in this box, right? It saves you some time there. All right, so if you need to see kind of more of the drawing, you can also always use these zoom in and out to capture the full perspective of the drawing you're looking at. And then the next process that we want to do is put this out into an Excel, or we also probably want this balloon document, right? Because we're going to eventually print this out with our Excel sheet, take them over to the inspection room, and then go and inspect the actual part. So we can do either PDF, Excel, or do it all in one step. So I'll click PDF and Excel. Save this one, finished housing balloons, parts list, and here's what it's going to give me. So the parts list hasn't really changed much, but the drawing has, right? It's got all the zones on them and all the balloons and everything else that we'd need there in that regard. And then if I go back to the SOLIDWORKS Inspection, it's waiting for me to export the Excel again. And so here's the ones that come in with the standalone product. Sort of the same ones as before. If you have the Pro, then these M-Expert ones would interest you, because it gives you the measurement expert options for when you're entering the results in the inspection window. But I'll pick this image captures, click the export, and then we're going to get a similar output as before. Right, so we've got our image captures here for our welds on our surface finishes, and it's appropriately calculated all the upper and lower limits, and it's indicated what method we should be using as we specified. Okay, so back here, let's take a look at one more thing. So I missed on the geometric tolerance. Let me click on that and draw a box there. So when you use the geometric tolerance, it will output this image on the Excel when you export it, or if you want to make sure that this comes in, you can go under the General tab and then rebuild the geometric tolerance. So right in this bar right here, you can click and then just rebuild this. So I'll say it's a parallelism. You can also draw a box within the image you've captured and then click here to recognize that text. And then for the datums, those you just have to key in. But I did want this 0.1 to be maximum, so I'll click in there, make sure I got it, and then maximum. All right, so now I'm ensured that this image will come out on the Excel sheet. Otherwise, it would just pop out with this image that you drew a box around, so it should probably be okay anyway. And it's worth noting that, like let's go to the surface finish one. You notice for type, if you've chosen the wrong tool to draw your box around, you don't have to delete it and redo it, which you can. You can just click on the balloon, click delete, or you can right click in the bill of characteristics and delete it. but you can just change the type. So if this should have been a dimension, I can change the dimension. The same way for geometric tolerances and notes. There's also some subtypes for other, so you can have it pull out sort of any of these specific types, and really it's just going to say this is this type, here's the image you've drawn, check for whatever this is that you specified. Okay, so we've exported that to Excel, and so that looks good. And if you're interested in editing the templates from the standalone, click on the SOLIDWORKS little circle here, and then there's a template editor. Click on that. Choose which template you want to modify, and then you have the full functionality of, adding more information, accounting for some of the sampling, however you want to build that. Sky's the limit as far as editing those Excels. Anything that Excel can do, the template should be able to build that in for you there. All right, so we've got all that. Looks good. Okay, so that was the standalone product, right? Beginning the project for the standalone using the optical character recognition and export to PDF and Excel. So it's very important to know if you want to use a SOLIDWORKS drawing to use the SOLIDWORKS add-in, if you want to use the PDF or TIFF to use the standalone version. And as far as the accounting for the bill of materials for Form 1 and 2, the standalone one will handle that. The SOLIDWORKS one, you just kind of got to put that in yourself afterwards. So some key differences that are important to note, important to know which one you want to use. But again, you don't have to buy them separately. They come all together in a nice package. Of course, every Wednesday we've got our e-learnings, right? At 11, it's the e-learning, which we do more of a step-by-step how to do something, and then at 1 is the e-demo, which is more of just showing you what the product does to get you a little more interested in that product. So we've got, of course, electrical, enterprise, PDM, CAMWorks, SOLIDWORKS. Those are our e-learnings coming up, and then mechanical, conceptual, SOLIDWORKS, sim and plastics, and CAMWorks e-demos also coming up. So please attend those and take a look. Those are really informative and always great. And if there's no other questions, then thanks for attending. Please visit our webpage. We're constantly updating it, adding new things to our YouTube, and great videos there. Hopefully there'll be some more inspection videos that we're all working on over here. But again, SOLIDWORKS Inspection is just been out since April. Before that, it was just a Gold Partner add-on, but now it's its own nice product that's real fully integrated within SOLIDWORKS, and it's really great and easy to use. So if you have more questions, always contact our tech support or contact our account manager if you're interested in the differences, like on product pricing for inspection standard versus professional. So there's our support numbers there.